Okay, so we are ready to begin our first real Arduino lesson, and in this one we're going to learn how to do the most fundamental of interactive electronics with your Arduino, and that's to make light. If you just add a little simple light to any piece of artwork, it makes it cooler to look at, it makes it a little more interactive, it can make it more powerful, especially if you add the light in a directed, focused way. And so let's take a look at how to create light and how to program it to focus your light and time your light. For the supplies you'll need for this experiment, we're going to need 2 LEDs of any color, but make sure they're the LEDs with 2 legs only. The 4-legged LED is special and it works in a special way, so don't use that one just yet. You'll also need 2 resistors, and those resistors are 220 or 330 ohms. If I gave these to you on one of these strips, you can see it says 220 on the piece of paper on the strip, so use that one. Or you might recognize it by the color bands that are on it. 220 ohm resistors are red, red, brown, and 330 ohm resistors have orange, orange, brown stripes. You also need 3 jumper wires, and they should be the male-to-male jumper wires, and your Arduino, your USB cable, and your breadboard. Now, by now, you've probably gotten a little bit of background on how circuits work, and if not, you'll go through that with your teacher in class. So I'll just talk you through how to set up the experiment. On these LEDs, you should notice that your LEDs have one longer leg and one shorter leg. So I'll pluck one out here so I can show you. On my LED, it's a little hard to see here, but there's a longer leg here and a shorter leg, right? And on these LEDs on my program, I've got one with a slightly bent leg and one with a straight leg. So let's pretend the slightly bent leg is the longer one. The longer leg is important because that's the direction that has to be pointed toward the positive voltage source. Electrons can only flow through an LED in one direction, so you have to make sure the shorter leg is going toward ground and the longer leg is going toward the voltage source. So when we plug these LEDs in, we're going to plug them in the breadboard so that the 2 legs are in different numbered rows. As you look down your breadboard, there are numbers, and some breadboards have letters going across. We're going to ignore the letters for now and just focus on the numbered rows. One thing that we need to know is that all of the pins in any numbered row are connected together. So if I click on one on my software here, I can see all of these pins light up. That's because they're all connected together. So if I plug something into row 1, and then I plug something else into row 1, those 2 things are going to be connected together. I thought maybe, yeah, I did. I accidentally created a wire there. I didn't mean to. So anything connected in row 1 is going to be connected together. Anything plugged into row 2 is going to be connected together. However, rows across the valley are not connected. So these pins in row 1, F through J, aren't by default connected to the pins in row 1, A through E. Also, on the breadboard, anything in these power rails is also connected together. You can see in my software, if I click on one of these pins in the blue rail, they all light up. So these are all connected together. And then on this rail, they all light up, so they're connected together. The reason why these rails are connected is these are usually the power rails. So it's common to plug your plus 5 volts power source into the red rail and your ground into the blue rail, and then anything that needs a ground connection will be connected together. So a little bit of breadboard knowledge for you. Let's take the LED, and the long leg needs to be plugged into a different row than the short leg. So I'm going to plug the short leg into, say, row 1, and the long leg into row 2. I'll take my other LED, and I'm just going to skip a row just to give more space here. So the short leg will be plugged into row 4, and the long leg will be plugged into row 5. Okay, so the long leg, remember, needs to go toward the voltage source, and the short leg to ground. Now, a little trick for making these circuits work is we're going to use these resistors. A resistor is really important if you're using just plain normal LEDs, because an Arduino can push out enough current that it could pop the LED and make it smoke, and we want to avoid that. So the resistor slows down the electrons a little bit so they don't flow quite so fast, and then we won't pop our LEDs and burn them out. So it just slows down the electrons a little. We're going to take one of the resistors, and then one of the legs is going to go in the in the same row with the short pin of this LED, so row 1. And just kind of take your resistor, and let me show you with this one here. Take your resistor and bend the legs so they kind of come down at a right angle, like this. So it looks like a little, like a croquet wicket or something like that. And then one of these gets plugged into the same row as the short LED. And the other one of those legs, I'm going to draw a line here, will go into the ground rail right there. Anywhere in the ground rail will do. Okay, your other resistor is going to do the same pattern, but with the other LED. So one of the legs goes into the same row as the short leg, and the other leg of that resistor goes into the ground rail, anywhere in the ground rail, and that's the blue rail of your breadboard. Okay, so short leg of LED in the same row as one leg of the resistor, which goes to the ground rail. Short leg of LED, one leg of the resistor, ground rail. Now what do we do with those long legs of the LED? Those long legs have to go to a voltage source. But in this case, we're going to, instead of like the plus 5 volts voltage source, we're going to use the numbered pins on the Arduino, and it's going to put voltage out according to a computer program. So get a jumper wire, and you're going to plug one end of the jumper wire in the same row as a long leg of the LED. So this will be row 2. And the other end of your jumper wire is going to go to pin, let's do pin 3 for this top LED. Okay, so find the pin on your Arduino that has the number 3 next to it, and you're going to plug the other end of the jumper wire in there. Next, we'll do the same thing with the other LED. Find a row connected to the long leg, and then take that wire, and it's going to go down to pin 2 of your Arduino. Find the pin that's labeled number 2. You'll need to look very carefully, really squint at it if your eyes aren't so good, and make sure that that gets plugged into pin 2. I'm going to make these different colors just so they stand out. You can use any color wire you want. They do not have to be blue and yellow. Okay? So long leg, pin 3. Long leg, pin 2. Finally, in order to complete the circuit, remember how I said you have to have a voltage source, which right now is one of these pins. You have to have a load, which is the LED and the resistor. And then it has to have a complete circuit. So it needs to finish the path by going to ground. So we're going to connect something in this blue rail, any pin in this blue rail, to a ground pin on the Arduino. There are 3 ground pins. They're all the same. Here's a ground, and there's also 2 grounds over here on this other side of the Arduino where it says power. They all do the same thing. You can pick any ground you want. Take a jumper wire and plug one end into the blue rail of your breadboard, and the other end into any pin that's labeled ground, GND. I always like to color this one black because that's a common color for the ground rail. And I'm just going to put a couple of bends in it so it doesn't cross over those other wires, but it does not matter if they cross over in real life as long as metal isn't touching metal. Okay, that's all the wiring that you should have to do. So double check your work and make sure everything's wired up correctly. Don't plug in your Arduino yet. We'll plug it in the next step, and that's when we write the code. So let's go on over to our Arduino software in order to do that. In the Arduino software, but when you first open up your software, you're going to have 2 functions, void setup and void loop. Now when we did work in processing, these were named differently. One was called setup and the other was called draw. And you remember one of them ran once at the beginning of your program and the other ran over and over forever. That's the same structure here with Arduino. Setup is run once at the very beginning, and loop is run over and over again very fast forever. Loop on Arduino runs a lot faster than draw does in processing. Draw in processing is meant to run at kind of a slow frame rate, about the same frame rate that your eyes perceive animation. But loop in Arduino will run as fast as possible, and so it can run so fast that your eyes can't perceive it. So what we're going to do is in setup, it's really important to configure your pins. We are using pins 2 and pins 3. Pins 2 and pins 3 are going to be voltage sources. They're going to push electrons out, and so we need to configure them as outputs. We do that, so go in between the curly braces and void setup. You want to make sure you create a blank line before this closed curly brace, okay? And here on this blank line, you'll type in pin mode with a capital M, do an open parentheses, and since we're going to configure pin 2, we'll do 2, comma, and then you type the word output in all caps. Output, end the parentheses, and do a semicolon. 2, comma, output. Since we're using pin 3, we're going to do the same thing with pin 3. I'll copy this line, and then go to the end of that line and hit enter, and do Control V to paste it. And let's change the 2 to a 3. So pin mode 2, comma output, pin mode 3, comma output. That's run once during setup. We don't need to do anything to configure ground, it's already configured. Next we're going to go into void loop. And in void loop, we'll use the commands that are going to make these lights turn on and off. So inside void loop, we'll do a digital write, and then we'll write pin 2, comma, high in all caps. So what this command does, digital means it's either on or off. There's no in between. And then for pin 2, that's the pin we're using here. High means it's going to put 5 volts on that pin. And then 5 volts will go through this wire, through the LED, through the resistor, down through the ground rail, and then over here to ground. Okay? Next, that'll turn the light on. We're going to add a slight delay so we can enjoy the light being on before we turn it off. So we use the command delay. And then in delay, we're going to put a number that represents how long the delay we want the delay to be. This number is in milliseconds, so 1,000 is 1 second. I want it to be about half a second, so I'll do 500. And use a semicolon at the end. After a 500 millisecond delay, we're going to turn the light on pin 2 off. So I'll copy those 2 lines, Control C, go down one more and hit Control V, and then I'm just going to change the second digital write. Instead of 2 high, we're going to change it to 2 low. Okay, everything looks pretty good so far. So we'll go ahead and upload this program. Make sure you go to Tools and verify that your board says Arduino Uno, and then make sure that your port is the correct port. I have 2, but there's a good possibility you only have 1 here. If one doesn't work the first time, try the other. So make sure your Arduino is plugged in, and then you'll go ahead and click Upload. Okay, and it may, it's asking me to save my program. I will call this Blink 2. Okay, so it's saved, and now it says it's compiling the sketch, it says it's uploading, and at this point you should see the TX and RX lights on your Arduino blinking very fast. My cable's really short, so I can't really bring the Arduino over here to show you, but now I can show you here. There's one light blinking at a rate of, once it turns on for 500 milliseconds and then off for 500 milliseconds. So we're getting about a 1 per second rate of blink. So at this point, if you know how to get the other light to turn on, I encourage you to go ahead and pause the video and do that. If you're not sure yet how to get the other light to turn on, then stay with me and I'll show you how. One moment. Okay, are you ready to get the other light to turn on too? So the way to get the other light to turn on is, of course, we are going to use these same digital write commands, but instead of pin 2, we're going to use pin 3. Now there's a few different ways that we can do this, but one fun way might be that when maybe when the light on pin 2 goes on, we're going to turn the light on pin 3 off, and when the light on pin 2 turns off, we're going to turn the light on pin 3 on, so they toggle back and forth. So this is what it looks like when we do that. Right below where it says digital write 2 high, we're going to say digital write 3 low. And then right below where it says digital write 2 low, we're going to say digital write 3 high. So again, make sure digital write is spelled correctly, and that's a capital W. So with these 2 commands, one right in a row, it will turn on pin 2 and turn off pin 3, and this happens, turn on pin 2, turn off pin 3, and this happens very fast. You can't even perceive that these 2 happen at different times. And then it waits for 500 milliseconds. And then it's going to turn pin 2 off and turn pin 3 on really fast, and then delay another 500 milliseconds. So you'll see the result of this when you hit upload. And it's probably saving my program. Okay. And now you can see my 2 LEDs are blinking, like toggling on and off with each other. And you can play around with like timing and the order of the commands, and see if you can make the lights turn on in different interesting lighting patterns. If you feel like you want to experiment a little bit, add a couple more lights. I think I included enough in your kit to do 3 or 4. And just play around with different patterns of lighting up, and you can really see the excitement that you can generate in artwork when you can make things light up. And I hope you enjoyed this lesson and it gave you a little bit of an idea of the potential of this technology.